Let me ask you something. What if I told you that a super simple thought experiment, one you can do in your head right now, completely blew up our understanding of gravity, of space, and of the universe itself? It's one of the most elegant and powerful ideas in all of physics, and it all kicks off with one simple question.
Okay, I want you to imagine you're standing inside a plain, windowless elevator. Got it? Now, in scenario 1, this elevator is just floating out in the middle of deep space, miles and miles from any planet. Then, all of a sudden, a rocket on top fires up, and the whole box starts accelerating upwards. You'd feel your feet getting pushed right into the floor. Now, for scenario 2, you're in the exact same elevator, but this time it's just sitting perfectly still right here on the surface of the Earth. And of course, you feel your own weight pressing your feet into the floor.
So, here's the big question. With no windows to peek out of and nothing to go on but that feeling of your feet on the floor, could you tell the difference? Could you do any experiment inside that box to figure out which situation you're in? Are you accelerating in space or just hanging out in Earth's gravity? And the answer, which is the absolute key to everything, is no. You couldn't. There's no way. That feeling of being pushed into the floor by acceleration is completely 100% indistinguishable from the feeling of being held on the floor by gravity. The sensations are identical. This brilliant little insight has a name. It's called the principle of equivalence. And it's just this simple idea that locally, in a small contained space like our elevator, you just can't tell the difference between being in a gravitational field and accelerating. So the takeaway here is huge. If two things are totally indistinguishable, then maybe, just maybe, they're fundamentally the same thing. I mean, no experiment you could dream up, dropping a ball, timing a pendulum, weighing yourself, none of it would give you a different answer. For all intents and purposes, they're equivalent. And look, this isn't just some fun little brain teaser. This one powerful idea is the absolute bedrock for Einstein's general theory of relativity. It's our entire modern understanding of gravity, and it all starts right here in this imaginary elevator. So, of course, this leads to an even wilder question. If acceleration and gravity are the same for you and, say, a baseball, are they the same for everything? What about something with no mass at all, like a beam of light? Well, let's hop back in our elevator and find out. All right, so we're back in that elevator accelerating up through deep space. Now, imagine someone shoots a laser beam through a tiny hole on the left wall. Light moves crazy fast, right? But it's not instantaneous. In that tiny, tiny fraction of a second it takes the light to get from one wall to the other, the elevator itself has moved upward a little bit. So the light will hit the opposite wall at a point that's slightly lower than where it came in. From inside, it would look for all the world like the beam of light just bent. Okay, now let's connect the dots. Remember our rule? The principle of equivalence. If acceleration makes light appear to bend, and we know that acceleration is indistinguishable from gravity, well, then you're forced into this incredible, mind-bending conclusion. Gravity itself must bend light. The principle demands it. Even though a beam of light has no mass, gravity has to affect its path, just like it seemed to in our accelerating elevator. And this is where it gets so cool. Because this isn't just some clever idea cooked up in a thought experiment. Nope, it's a prediction you can actually go out and test. And guess what? The universe has shown us, again and again, that Einstein was absolutely right. We can literally see the proof. Just think about astronauts on the space station. We say they're weightless, but it's not because there's no gravity up there. The Earth's pull is still about 90% as strong. The reason they feel weightless is that they and their spacecraft are in a constant state of free fall around the Earth. It's a form of continuous acceleration. And then on a much grander scale, we see it with something called gravitational lensing. When light from a faraway star passes by something massive, like our sun or a whole galaxy, we can observe that light bending around it. We are literally seeing the shape of space being warped by gravity. So what's the big takeaway here? The principle of equivalence doesn't just tell us what gravity does. It totally rewrites the rulebook on what gravity actually is. It forces us to toss out the old ideas and embrace a much stranger and honestly way more beautiful picture of how the universe works. For centuries, we had Newton's idea of gravity, this mysterious, invisible force that just pulls things toward each other. But Einstein's theory, which all started with that elevator, says something completely different. It says there is no pull. Instead, big objects with lots of mass and energy literally bend and warp the fabric of space and time itself. And other objects, They're just following the straightest possible path along those curves.
Think about that. You're not being pulled down to the floor by a force right now. The mass of the Earth has created a huge curve, a sort of divot in space-time, and you are just moving along the straightest path you can through that curved geometry. The feeling you call weight is just the floor pushing back, stopping you from taking that natural path. And that leaves us with one last really fascinating thought. A simple idea that an elevator on Earth feels just like one speeding up in space uncovered that one of the universe's fundamental forces is actually just geometry. It really makes you wonder, doesn't it? If something as basic as feeling your own weight isn't what it seems, what else about our reality is just hiding a deeper, stranger truth?